Hello friends, welcome to my channel. In this video, we are going to talk about something called as eMTC and NBIoT. If these terms are new for you, don't worry, we are going to talk about it. So as we see in the networks, in last decade, we have seen lot of human beings connecting to the networks. However, today if we look around, almost all of us are having one or two phones, and if not two phones, we have one or two SIM cards. So almost everybody have the SIM cards and the phone today. Now, if we look at the future growth of the telecom network, and that growth is not going to come from the human beings. So what we need to do is we need to connect lot of devices, lot of things to the network. However, we need to tweak our networks to connect lot of devices to the network, and that's exactly which is enabled by eMTC and NBIoT. So all these eMTC and NBIoT kind of services are typically related to things. Now you may ask, hey, if both of them are connecting to different kind of things, then why we are using two terminology, eMTC, which is called as enhanced machine type communication, and NBIoT, which is referred as narrowband IoT, how they're different and why we need two different type of services instead of one. So in this video, we are going to talk exactly about that, right? So what is eMTC, what is NBIoT, and why we are looking for two different services to connect lot of things to the network, right? Let's try to understand. So if you look at some earlier releases like release 8 or some release 8 for different kind of devices, which is like category 4 and category 1 kind of handsets. So our downlink peak data rate were 150 Mbps and it can be as low as 10 Mbps. However, if you look at the UE receive bandwidth, that is going to be 20 megahertz. So what does that mean? This means that even the users, so whether network gives you 150 Mbps or 10 Mbps, what user has to do is user should be capable of handling 20 megahertz kind of bandwidth. In release 12, we have introduced another category of handset which is called as category 0, and this category 0 also have UE receive bandwidth is 20 megahertz. That means user still need to understand 20 megahertz kind of bandwidth. That means user has to be very complex and user will consume lot of power. However, when we look at IoT related use cases, in most of the use cases, first of all, our device cost has to be kept very low, within couple of dollars. Also, their power efficiency should be very high. How do we really achieve it? To achieve that, we need to reduce the UE receive bandwidth, and that's what exactly we do in the eMTC, where users can operate as low as 1.4 megahertz. To bring it down further, we can even bring it down to 200 kilohertz in NBIoT kind of architecture, right? So if you look at this, the eMTC can support data rates of 1 Mbps downlink and uplink. The category of the handset is referred as Cat M1. In case of NBIoT, UE can operate at a bandwidth of 200 kilohertz and downlink peak data rates can be as low as 200 kbps and uplink can be as low as 144 kbps. But if we look at these data rates, they are not drastically different. So how they are different? Let's try to understand what are the typical differences between eMTC and NBIoT. Now, when you look at this, this is the eMTC category, which is category M1 handset, and typically this includes the very broad range of IoT application where we may need VoLTE kind of support as well as mobility kind of support. So these are the typical devices where you need to support some mobility as well as some voice call kind of functionality in these devices. However, if you look at NBIoT, where the handset category is referred as Cat NB1, it provides some extreme or mass level kind of use cases which are okay with very low throughput, very delay tolerant IoT use cases. This means these kind of devices can actually transmit data once in a day, maybe twice in a day. However, these devices may need to send some data every few seconds, every few minutes, right? That is one. Secondly, these devices may support some kind of mobility of the users, but these devices may be static to a particular location, maybe checking a pressure valve, or maybe connecting to a factory, or maybe a water sprinkler, these kind of use cases. So these are going to be massive in number, but with very low mobility, very low throughput, and can have lot of delays in transmitting the data. These devices are not going to be massive in numbers, but they support mobility for the end users. This can be some kind of smart watches, some kind of refrigerators, some kind of phones, and some kind of bikes, etc. Right? So typically we have these kind of different use cases. So some mobility support kind of use cases are actually supported by eMTC, which can give you around 1 Mbps kind of data rate, and NBIoT kind of use cases where you are also okay with 200 kbps kind of data rate, fault tolerant, and very low throughput kind of use cases. So that's the typical difference what we have in the eMTC versus NBIoT. However, to support these use cases in the wireless network as well as in wireless network as well as in the packet core network, we need to tweak our radio network as well as in the core network. In some upcoming videos, we are going to talk about the detailed network architecture whenever we want to introduce eMTC and NBIoT kind of services. That's all what we have in this video. In some upcoming videos, we are going to talk about the LTE EPC interfaces and protocols. Thank you very much and see you in the next video.